Okay, looking at numbers 3 and 4, the identities, these end up being pretty easy identities. Just make sure that you're using your sum and difference. So when you see the cosine of one angle minus another one, you want to use your formula. Cosine of alpha minus beta says you take the cosine of the first, so we're just going to write that out, cosine of pi, and you have to show that step because this is an identity again. Cosine of the first angle times the cosine of the second. My second angle is theta. And then the formula says if you're taking cosine of alpha minus beta, then you're going to use a plus sign, and then you're going to take the sine of the first angle, so sine of pi, times the sine of the second. So that's just using the formula, and for an identity you do need to show me all of that. Now we're going to simplify. The cosine of pi, remember pi's over here, well, see, you can't see that. Pi's over here, so that has an ordered pair of -1, 0. So the cosine is -1. I don't know the cosine of theta, so I have to leave that. The sine of pi is the y value, which is 0. So show me it's 0 times the sine of theta. And so now when I go to simplify this, 0 times anything is 0. -1 times cosine theta is negative cosine theta. So it ended up being a pretty easy identity. You just use your difference formula for cosine. Cosine of the first, cosine of the second, plus sine of the first, sine of the second. Then simplify the trig values you know, and then you can simplify the whole thing. All right, so let's do the same thing with number 5. Number 5 says you have the cosine of alpha plus beta plus cosine of alpha minus beta. All right, so let's use our formula on this one. Cosine of alpha plus beta is the cosine of alpha, cosine of beta, and with the plus then we have a minus the sine of alpha, sine of beta. Okay, plus, so that's just this for this piece right here, plus the formula for that, the difference is you're going to take the cosine of the first times the cosine of the second plus the sine of the first, sine of the second. And I might have to make this a little bit bigger for you to see that. Okay, so I just used the formula on the cosine of alpha right here, of alpha plus beta, plus the cosine of alpha minus beta is right here. So then I look to see, is there anything I can simplify? Well, here I have sine alpha sine beta and negative, and here I have a positive sine alpha sine beta. They're going to go away. Then I have a cosine alpha cosine beta plus another cosine alpha cosine beta. So how many of those do I have? I have 2 of those. And that's it. That's all I had to do to show that. It's expand everything out with the sum and the difference formula and then add like terms. That's it. Okay, so let's flip over and see how much of this I can get started on. I may have to finish it in another video or just post the answers. I can get you started. So with this, you first have to figure out the cosine of alpha is 3/5. They tell you what quadrant it's in right here. Here's -pi/2 and here's 0. So it's in between those two, which means it's in the 4th quadrant. So first of all, I know it's in the 4th quadrant. I need to use my Pythagorean identity for alpha. I'm going to take the cosine alpha squared. I guess I can write that out. I know what the cosine of alpha is. Cosine of alpha is 3/5, so cosine squared plus the sine of alpha squared has to equal 1. Cosine of alpha squared plus sine of alpha squared has to equal 1. So now we just have to solve for the sine of alpha. We're going to square this, square both the top and the bottom, 9/25. Subtract 9/25. What's that? 25 minus 9 would be 16/25. And take the square root and realize we have to decide if we're going to take a plus or the minus of that. And because it's down here, the sign will be negative, so it's negative. And so when I take the square root of 16 over 25, it comes out evenly to 4 over 5. So -4/5, which is a nice fraction to work with. So I know the cosine of alpha here, I know the sine of alpha here. We do the same thing over here. We have to find, with this one they're given the tangent is 5/12. So now I can either use tangent squared plus 1, I could use that. Tangent squared beta plus 1 has to equal the secant squared beta. We can use that formula. Once we have the secant, we can flip it to get the cosine. We can do what we did in the other chapter and say, all right, tangent is sine over cosine or y over x. So if this is 5 and that's 12, I could go off the unit circle and see what that was, and then use my sine and cosine identities. So I don't really care which way you do it. I guess I could show you both ways and then maybe get this piece, and then I'll do the rest of it in the next video. So let's say we use this one, tangent squared plus 1 equals secant squared. So if I have tangent squared, I write that down. Plus 1 has to equal secant squared. Beta, we're dealing with beta now. So this would be 25 over 144 plus 1, which is 144 over 144, equals secant squared. And so this would give me 169 over 144 equals secant squared, which would be 13/12 when I take the square root of both. And the secant, because it's in the first quadrant, would be positive, so it's 13/12 is the secant of beta. But I don't really need to know the secant in my formula. I need to know the sine and cosine. So if the secant is 13/12, the cosine of beta is 12/13. And from my picture, I kind of also know that if I know the cosine is 12/13, then the sine would be 5/13. If I didn't know that for sure, after I get the cosine, I'd have to say cosine squared plus sine squared equals 1. And solve for sine squared. I get 144 over 169. Subtract 144. I get 25 over 169. Take the square root. It's going to be positive. It's in the first quadrant. So the sine of beta would be 5/13. Okay, so you got your cosine of beta and your sine of beta. Now, if you did it the other way, so if you didn't use these Pythagorean identities, you could draw your picture. You would say, okay, I'm off the unit circle, but my y value is 5, because this is y over x, and my x value is 12. And then use Pythagorean theorem, 12 squared plus 5 squared has to equal r squared. And I get 144 plus 25 is 169. So r would be 13. And then once you have r, you can say, all right, then sine is 5 over 13, cosine is 12 over 13. So either way works as long as you can find that sine and cosine. All right, and then I think what I'll do, I can talk about how I do each of these. I think I'll just post the answers. So once you have your alpha, your cosine of alpha, sine of alpha, cosine of beta, sine of beta, now you're just going to use your formulas. So that was really the hardest part. So like this one, you're going to take the sine of alpha. So you would say, okay, sine of alpha is here, -4/5, times the cosine of beta. I've got the cosine of beta. And I'm doing plus, so I'm using the plus sign, cosine of alpha, and sine of beta. And then you would just multiply those out to get your answer. And this would give me like -48 over 65 plus 15 over 65, and that would give you -33 over 65. And I don't think that reduces, so that would be your final answer. Okay, so that, and you do the same thing, cosine of alpha minus beta. When you get to tangent of alpha plus beta, again, you're going to have to find the sine of alpha plus beta, which you already did up here, so you don't have to redo the work. You did it in part A, over the cosine of alpha plus beta. That you didn't find, so you're going to have to do some work on that one. Cosecant of alpha minus beta, find the sine of alpha minus beta, which you haven't done, you'll have to do. Find the sine of alpha minus beta, and then once you get your answer, you're just going to flip it. It's going to be 1 over that answer. You're just going to take your answer, and you don't even have to put 1 over it. You can just take whatever the answer is and flip it. Okay, take its reciprocal. And then the other one down here, cosine of 2 beta, we don't have a formula yet for the cosine of 2 beta, but what we can do is think of this as the cosine of beta plus beta. That's what 2 beta is, it's just beta plus beta. So now when we go to use our cosine formula, we're going to take the cosine of the first, so we're going to take the cosine of beta, which you know what that is, times the cosine of the second, which is also beta. And because we have a plus sign, we're using a minus, and then the sine of the first angle, times the sine of the second angle. So now we just fill these in. What is the cosine of beta? It's 12/13. So we do that twice. What's the sine of beta? The sine of beta was 5/13. We're going to multiply that by itself. And then we're going to get our answer. This would be, what, 144 over 169 minus 25 over 169. So I'm going to get 119, I think, 119 over 169 without a calculator, doing that fairly quickly to get that answer. And if that's different, I'll change it on the answer key. But I'll post the answer key, but I just basically want to make sure you could find these four things up here to make sure you got those answers correct. And then everything's filling things in until you get to tangent. You have to know you have to take the sine over the cosine. Cosecant, you have to find the sine of that angle that you're looking at and then just flip it, find its reciprocal. And then this one you could think of as the cosine of beta plus beta. And then just put it out. Since they're both the same angle, it's the cosine of the first, cosine of the second. That's the same thing. Minus the sine of the first and sine of the second. And then fill those things in and get your answer. Okay? So I'll post the solution to this, a picture of the solution, and you can look at that as well. Hope that helped.